Assalamu alaikum, dear students. You're welcome again with your teacher Gr11MS Yassin in our lesson Limits and Continuity Part 3b. At the end of this video, you will recognize piecewise functions and define continuity of a function, then interpret it graphically. Don't forget to prepare your textbook, your pens, draft papers, your copybook, and your calculator. What's a piecewise function? A piecewise function is defined by at least two expressions, each of which applies to a different part of the function's domain. Example, let f of x be minus x if x is less than 0, and it's defined by x when x is greater than or equal to 0. Does f have a limit at 0? Let us justify our answer. First, this is a table of values of x. You can see how they change and how the values of f of x also change. When x is less than 0, these are the values. F of x equals to minus x. And when x equal to 0 and x greater than 0, f of x equals to x. And this is the graphical interpretation of it. The limit of f of x as x tends to 0 plus. Since 0 plus is greater than 0, we find the limit of x as x tends to 0 plus, which is 0. And to find the limit at left as x tends to 0 minus and 0 minus is less than 0, then we take the limit of minus x, which is minus 0, which is 0. In this case, the limit of f of x equal to 0 as x tends to 0, so we say the limit of f of x as x tends to 0 exists. Application 1. Let f of x be the function defined by x plus 3 for x greater than 2, and defined by 3 when x equal to 2, defined by x plus 1 when x less than 2. Find the following limits, but please stop your video to find these limits. The second question, can we say that f admits a limit at 2? Justify your answer and pause your video to answer this question. Now, a summary of our lesson. Don't forget all the notes we have taken from the first video till now about limits. Continuity of a function. The definition of the word continuous. A function is said to be continuous over an interval I when its graph is a single unbroken curve that you can draw without lifting your pen from the paper. Example. According to the previous definition f, the function f is defined in the previous example is continuous at 0, but g is not continuous at 0. And we can find this is f, which is continuous at 0. There's no unbroken curve. And this is a g, which is discontinuous at 0. Property. Give a function f defined over an opened interval I. F is continuous at a point A belongs to this interval I if limit of f of x as x tends to A equals to f of A. In other words, we can say that the limit at left, if it's equal to the limit at right and equal to f of the value A, then we can say that f is continuous at point A. A remark, A function f is not continuous at a point is said to be discontinuous at this point. Geometrical interpretation. We can see this curve. You can see how it is continuous at 1. There is no gap, no hole. See how it is drawn without any broken. The second graph, you can see here f is not continuous at 2, and you can see that there's a gap. See how the hand is drawing, and it has a jump to complete drawing. Your assignment, please, if you missed some details, watch again the video. And you're welcome, dear students.